Let's determine whether functions are even or odd. Example A, f of x equals x squared minus 5. Keep in mind, if a function is even, I should expect to see that if I plug in a negative x value, I'll get its positive y value. I should get the original function itself. If a function is odd, if I plug in its negative x value into a function, I should get its negative of the original function itself. So in this case, if I plug in negative x, then what I'm doing is for every variable I see there, x, I'm going to plug in negative x and leave everything else the same. From there, I'm going to simplify. So f of negative x is equal to negative x squared. That would be negative x times negative x. Negative times negative gives us positive, so this is going to give us x squared minus 5. Now how does x squared minus 5 compare with our original statement of x squared minus 5? Oh, they're the same thing. So what this is showing me is that f of negative x equals f of x, therefore saying that this is going to be an even function. Okay, to verify this, let's graph it to see its symmetry. Graphically, what we're dealing with is, in terms of x squared minus 5, that would be a parabola, but it has a transformation. Negative 5 tells us to shift down 5. So I'll go 1, 2, 3, 4, 5. And then from there, I know I have a parabola going upwards. And right there, we also know that based on the x-intercepts, right, x squared minus 5, we have an intercept at root 5, 0. And also the other intercept would be negative root 5, 0. And so for that reason, you can see here that you do have that symmetry with respect to the y-axis. This would be an even function. Let's do example B. G of x equals x cubed minus 1. Again, if you plug in its negative x value, let's see what we end up getting. I plug in negative x into the variable, and then we simplify. So g of negative x is equal to negative x times negative x times negative x. Well, that would be the same as negative times negative times negative. That'll give us negative x cubed minus 1. Now, how does this compare with our original statement? Well, let's try to modify it a little bit. Let's try to make it as close to our original statement as possible, which means let's factor out the negative, and we'll end up getting x cubed plus 1. Okay, let's see. How does that compare? Well, g of x is x cubed minus 1. Right? Did we actually see that we get the exact same equation? No, it's not the exact same. So therefore, this is definitely not going to be an even function. Let's see if it's odd. We had to have gotten that g of negative x has to equal negative g of x. Well, that's saying negative x cubed minus 1. That's what we want. Is that what we have, though? Even if you distribute that negative into everything, or actually, you can actually see how this is negative, but we have x cubed plus 1, but what we want is x cubed minus 1. So this is not odd either. So therefore, you would say this is a neither equation, function, because it's not even, it's not odd. Graphically, what are we dealing with? X cubed minus 1 is another transformation. You have a cubic function, but it got shifted down 1. So your graph would look something like this. And you can see here that it is not symmetric with respect to that origin because of that shift down 1. If there was no shift, then you would have an odd function, but in this case you don't.